All right, let's jump right in. Today, we're going to tackle the absolute bedrock of C programming. We'll be breaking down how a computer actually stores and works with information, starting right from square one.
Seriously, have you ever really stopped to think about it? How do computers, remember things? When you type your name into a program or enter a number, how does it hold on to that information? Well, it's not magic, that's for sure. It's a system, and we're about to crack it wide open. The easiest way to wrap your head around all this is to think of C programming like learning any new language, right? You can't just start writing a novel. First, you've got to learn the basic words, the grammar, the punctuation, all the building blocks.
Okay, so let's grab our first building block. It's called a variable. And if we're sticking with our language analogy, variables are basically the nouns of C. They're the names we give to all the things we want our program to talk about or, remember.
So yeah, that's the textbook definition. But here's a much simpler way to think about it. A variable is just a name tag you slap on a little storage box inside the computer's memory. And inside that box, you can stick whatever piece of info you want, a number, a word, anything.
All right, so we know what a variable is, but now we got to learn the grammar. You can't just name them whatever you want. Just like in English, you can't invent spellings for words and expect people to understand. C has rules, and you have to follow them, otherwise the compiler is going to have no idea what you're talking about.
And this right here lays it out perfectly. Look on the left, those are all good, valid names. See? You've got underscores, letters, numbers, totally fine. But on the right, you see the stuff that'll break your code. Spaces? Nope, can't do it. Hyphens? Also a no-go. And this is a big one. You can't use a word that's already a special command in C, like float.
So, let's quickly nail down these key rules. First, you can't use those special keywords. Second, your variable name has to start with a letter or an underscore, never a number. Third, no spaces or weird special characters. And finally, and this trips people up all the time, C is case sensitive. That means my name with a capital N is a totally different variable than my name, all in lowercase. You've got to be precise.
Okay, so we've got our storage box, and we've given it a name. But what are we actually putting in the box? Is it a number? A single letter? A decimal? We have to be specific and tell the computer exactly what kind of information to expect. And that, my friends, is where data types come into play.
So in C, we've got 4 really basic or primitive types to work with. You've got char, which is just for a single character, like the letter A. Then there's int. That's for integers, whole numbers like 10 or -50. And for numbers with decimal points, you have float and double. The main difference? Just think of double as the bigger, more precise cousin of float. It's for when you need a lot of numbers after that decimal point. But hang on a sec. What if you have a value that should never ever change? I'm talking about something like the value of pi. You want to use it in your code, but you need to make absolutely sure that you or someone else doesn't accidentally change it from 3.14 to, 72.
Well, C has a perfect tool for that. It's a special little qualifier called const. When you put const in front of a variable, you're basically telling the compiler, hey, see this value? It's read-only, set in stone. Don't you dare let anyone change it. It's an awesome way to protect your really important data from being messed with. Okay, now for something a little weirder. What happens if a value changes, but not because of anything your code did? What if something totally outside your program messes with it? How do you even deal with that?
This is a bit more advanced, but C gives us another qualifier called volatile. A perfect example is a variable that's tied to the computer's internal clock. Your program isn't the one updating the time, right? The computer's hardware is doing it constantly. Using volatile is a signal to the compiler that says, hey, this thing can change at any moment, so don't try to be clever and optimize. Always go grab the freshest, most up-to-date value from memory.
Okay, this is where it gets really cool. We've been talking about these ideas, these data types, but how do they actually look inside the computer's memory? Well, each type takes up a different amount of space, which means it can hold a different range of numbers.
And this table breaks it all down for us. Just look at it. A char is super small, just one single byte of memory. An int takes up 4 bytes. A float, also 4 bytes. But check out double. It gets a whopping 8 bytes. And that's exactly why it can be so much more precise. Oh, and see that last column? That format specifier? That's just the special code you need to use when you want to actually print one of these variables to the screen. And to really put that range thing into perspective, look at this number. That is roughly the biggest number you can possibly cram into a double. That is a 1.7 followed by, get this, 308 zeros. That's just mind-boggling. And that's the kind of power you get from just 8 little bytes of memory.
All right, we've got our nouns, the variables. We know what kind of nouns they are, the data types, but to actually do anything, to make things happen, our language needs verbs. And in C, our verbs are called operators.
It's really simple. An operator is just a symbol that tells the compiler to perform some kind of action, and you already know most of them. We're talking plus, minus, multiply, divide, all that stuff. They're the tools that let us actually do math and manipulate the data in our variables.
So let's see how this works. Imagine we have two int variables. Let's call them a and b. We'll put 9 in a and 4 in b. So a plus b, that gives us 13. Simple enough. A minus b is 5. A times b is 36. Now division gets interesting. Since these are integers, a divided by b, so 9 divided by 4 gives us 2. It just drops the decimal part. And that little percent sign, that's the modulo operator. It just gives you the remainder of a division. So 9 divided by 4 is 2, with a remainder of 1.
And that's really it. That's the whole foundation. You've got variables to hold your data types to tell the computer what kind of data it is, and operators to actually do stuff with that data. I'm not kidding. Everything you will ever build in C, from a tiny little calculator program to some massive complex video game, it's all built using these 3 fundamental ideas.
So, there you have it. You now know the basic nouns, the grammar rules, and the verbs of C. You literally have the tools you need to start having a conversation with your computer. So the only question is, what's the first sentence you're going to write?